Right, okay, I'm pretty sure we are live, with apologies for the delay. It turns out I hate computers. It's a wonder why I'm doing the job I do. But I think I've got well, I've got the chat up here, so you can send your questions. And this is N Simulator, so we want to see it about like here? Yeah, okay, N Simulator live. This is the preliminary material. Anyway, this is AQA Computer Science Paper 1, which is in 10 days, like Wednesday week. And we were doing N Simulator. We were actually working from the... Oh, there's more. There's more. I'm very rusty. I've not done this in more than a week. But we'll... what was I usually using? Yes, Pio4 coding tasks, shut that, and we had done like 18, 19, I can't remember where we were. Done that one. Disease, yeah, we've done this one. That's like a not fun. The danger pheromone, which was weird, but like we did that. That's fine. We're all happy about this. And oh, all right, cinnamon, and then you get a little bit of biology, I suppose, and chemistry because of cinnamaldehyde, which is subjectively pheromone as well as navigate. It is like I don't know, like GPS scrambling for ants. Question: extend the skeleton program to introduce cinnamon in a cell. The cinnamon overrides the pheromone, removing it from the cell. And then looking for food will not enter a cell containing cinnamon. So this is going to be choose next, choose next cell to move to or whatever. Scent of cinnamon is so strong it also remove all the food from a cell. What? That is a very strong smell. Making the cell unappealing to a worker and for looking for food, which is like seems to be doubling with the fact that they will never enter a cell. Although an ant is already in a cell containing cinnamon doesn't die, it cannot update its pheromones in the cell or add new pheromone and introduce a new menu option to. So we're dropping cinnamon in the cell. You know what? I'm just gonna like hope for the best and just do it and copy, paste, rename. This is Z. I want to say 19. Yeah, or just Z. Z 19. Okay, here, that's slightly too big now. Quick here. So 6, new menu method, place cinnamon in a cell, no error handling, modify the cell class to identify when cinnamon has been placed in it. So cinnamon's going to be, like food, an attribute of the cell object. Okay, fine. So we kind of know how to do this. New menu option, meaning here, right? There's going to be a print print 6 dot add cinnamon, capitalize cinnamon. I suppose if it is the species single, and then an elif in here. Elif choice equal 6. Let's use this design pattern, right? You can initialize them. Don't really need to initialize them, but yeah, here. And then I'm gonna need a new method to kind of like add cinnamon to cell. I don't know if they've explicitly asked for a so it's remove pheromones from cell and modify the send class. And then we just have some ant logic. How you test this is kind of anyone's guess. We particularly since we're not asked to render them in the they're usually display details or whatever. If we can get details plural, like there's a couple, helper functions that help us as helper functions I want to do. So it's going to be remove pheromones from cell, and this is going to take coordinates. They said the new, in the simulation class. Yeah, okay. So this is going to be this simulation dot this guy at row column, which means column spelled it the same way, which means in my simulation class, this is a constructor, we get set up, whatever, at foot to cell. This is as good a place as any. Def this self row column pass, pass. So pheromones, right, are stored in the pheromones, capital P pheromones array, right? That's just a list of pheromone objects, which are entities that inherit things. So they will have a location in that they have row and column attributes because they are inherit the entities class. So to remove a pheromone, I feel like this array is the only place that references, as in hold references to pheromones object. And in programming, if you dereference an object, you don't need to explicitly say delete that variable. But if there's nothing that points to this memory location, then it considers it free, then it's garbage collected. Which means that removing pheromones from the cell becomes simply a matter of removing the pheromone entity from this pheromones list. And we know how to do this because I'm going to do for p in self._pheromones. Right, for each of the pheromones, I'm going to have a pheromones to remove, because, you know, each cell can contain more than one pheromone, but they have to be from different aunts, because when an aunt's layer pheromone, if there's already a pheromone that's from the same aunt, it just updates it and refreshes its level. Point is, we may have more at this one row column location, we may have more than one pheromone object. So we need a list. We'll initialize it as the empty list, and I do if. I've forgotten, I just have not worked this in a week. I've forgotten all of the, is it like a get index of getting, there's like a get index. Okay, what am I looking for? This, the outline will tell me, I don't need main, whatever, the simulation class. There we've set up nest add foot to cell, remove from to write, get index. This will give me the index of the cell. I can't really do a same location. I might need to just get a, I mean, I've got get row and get column from the entity class. Yeah, right. Get row, get column in same location as an entity. Fine. If they were, so like in that case, I'm not comparing, oh, this object is in that object, isn't that this object and that object are in the same place, or this entity and that entity are in the same location. But here I have an entity, well, I've got a list of entities I'm going to want to check the pheromones, but I don't have another entity to check it against. I only have the row and column that have been passed by the user. So I'm going to do this like some kind of, you know, so it's remove, no, can't spell it right. Remove pheromones from cell, which was there writing it. And so if p.getRow bracket is equal to row, and p.getColumn bracket is equal to column, then we are going to append pheromones remove dot append p. So far, so good, right? P is an entity, is get row and column, and I'm just checking against the ones that were given by the user, passed by the menu function from the main class. And now I have my lists of pheromones to remove, and now iterate over this. For p in pheromones to remove, self._pheromones bracket, no, it's dot, and it's pop for, no, pop is if you have the index, and it's just remove if you have the object itself. And if I go look for this little string, I will find it, right? You'll find this being done here. Look at that, there you go, right? Cell pheromones, we advance the stage of the pheromone. If it reaches 0, we add it to the delete array, and then we remove from pheromones to delete and p. This will remove pheromone from the location. Now the cell, if I'm honest, they're not asking us, this is a bit weird, because modify the cell class to identify when cinnamon has been placed into it. I can do that, but they also say the scientist removes all food from a cell, making the cell appear to work out looking for food. Is this, are they telling us here, how to do that, right? Because like length looking for food will not enter a cell looking cinnamon. And you might be able to do that by making the cell uninteresting by removing the food. But then the problem is that even the random walk, right? Like I don't know if the ant actually detects food next to it. I don't think it does, right? So this is in class workaround. In our choose cell to move to, that's the list of neighbors. That's a list of indices of neighbors in the self._grid array. That's an attribute of the simulation class. This is when it goes back, if it's carrying food, and then if it doesn't have anything, it chooses a random neighbor, right? It doesn't know even if there's one next to it that has food. It won't know that. It will just choose a random one, and you've got like 1 chance out of 8, roll the dice, that it will hit the one with the food. So making them, oh man. So making them avoid that is a bit trickier. I'm going to go to class cell, and then in here, I'm going to add an attribute which is self. False, and I guess I'm going to need to add a method to encapsulate it neatly. Just white space. Yeah. Don't like that. Don't like. Okay. Remove food from self. Just remove food. Self doesn't take anything else, and this will do self dot underscore amount of food becomes equal to 0. No, I'm just going to call that add cinnamon actually. Add cinnamon. So I'm keeping self amount of food to 0 because it wipes it. And just going to set that to equal true. Why do we do that? I think it's sort of the zigzag task collapse as we kind of like pass number 15. They're like, well, no student is like only 10% of the students will complete them up to that point, so we don't really need to kind of pay too much attention as to what's going on. So let's go to my remove pheromones from cell or add cinnamon, which was here. And now I need to iterate, no, I can do self dot, yeah, this one, right? Kind of self dot underscore get index. Fine. Row column. Actually, I'm going to say cell is equal to whatever is in underscore grid at the index that I get from the return of get index for this row and column. And just go cell dot, was it add cinnamon? This will, so this wipes the pheromones are not tied directly to the cell. It's just that both have a row and both live in their own little arrays, and they both have a row and column location, and we can check they're in the same location using in same location from the entity class. So if I just call add cinnamon in here, so which means that when you add cinnamon, this kind of like deletion by iterating, populate another list, iterate over the second list, use remove, that takes care of removing the pheromones, and then this find the cell that's for, you know, at this location, and then add cinnamon, meaning just remove the food, I guess. Then yeah, we'll do that. Now they said, yeah, add the required method to prevent the worker from entering or adding pheromones to a cell containing cinnamon. So it feels like there's no point if it can't enter it. If it can't enter the cell, then it's going to be able to add pheromones to the cell. But it is possible that when my user presses 6, they choose to add cinnamon to a cell that already contains an ant. So this is going to be a bit fiddly, but here we are. So let me just, where am I? So the ant movement and worker ant movement really is all here. We have choose cell to move to, which we were just looking at a minute ago. In that instance, mind you, there's a change cell. Maybe I can, Or choose random neighbor. I mean, this one feels open-ended. Okay, I'm gonna... There's also another circumstances where the ant could enter a cell. It's when it's carrying food back to the nest, and if I drop cinnamon like on the ant's path, then it's gonna need to enter that cell. That's kind of annoying because cinnamon wipes pheromone, right? Like, so there's 3 ways in which the ant can move, which are all in true cell to move to. This is when it's carrying food back. This is when it's looking for food, but there's no pheromone trail anywhere in the immediate like 8 squares around it. And this is when it's looking for food, but there is some pheromone in the 8 around it. Now that third one, because cinnamon wipes pheromone, then we know that it's never going to be the neighbor with the strongest pheromone because we've just wiped it. So in that mode, it's never going to enter that cell. In this mode, it could enter it because it's at random, and in that mode, annoyingly, it could enter it because it's just on the way. Now, I can't really, I would have to do something like it's that one, but like the one we're about to move to is, like this is just like literally clicking rows and column, like changing the values, but you'd have to do some really nasty conditionals to cater for that case. So I'm just going to say, look, if they're just working back, they just ignore cinnamon completely because they're already ignoring pheromone when they're working back. They're trying to do like a beeline to the, well, an ant line to the nest. So we're going to go to choose random neighbor, which I think, is it that one? No, it's going to be an ant then. Yeah. But then this is not, this is absolutely nightmarish because it's because the ant does not know about the rest of the simulation, although sometimes it gets past the list of neighbors, sometimes it gets past the indices of neighbors or whatever, but as a general rule, it doesn't have access to the cells of the simulation, so it can't check the pheromone flag we've just changed. It doesn't have access to pheromone array. I mean, not that it matters because we're just removing stuff from pheromone array. But like, I was hoping that I could do something like, well, choose the random neighbor, but if it happens to be the neighbor where, like, there is cinnamon, actually choose a different one. But I can't do this because at the workaround class level, or the ant class where this method lives, I don't know about the rest of the simulation. So yeah, I don't think they thought that one through. And usually when I encounter a zigzag task like this, I think the last time was 14 that really stumped me, and I go and look at their solution code, and it turns out that would not work anyway. It might pass their test though. Those are two different things. So this means I may need to go into my class simulation, and then def advanced stage did. Oh, not dev. Advanced stage of the simulation class, this is where most of the magic happens, right? This has got a whole bunch of stuff there. And here we kind of like looking at pheromones. This is getting lists of neighbors, right? This is when I'm going to get the neighbors and... Okay. Okay, I know what I can do. I think I've done this in some other place. Can't remember where it was, but like I just need to intercept this and say neighbors, like the Australian soap opera from the 90s. So this is going to return indices in the grid array. Yeah, I got a good feeling about this one. I can even do something quite Pythonic. So if I do like for n in neighbors, No, I can't do for finding neighbors. I need to actually, which is good because I'm not iterating over the list. I'm iterating over, I'm not going to be removing from the list. I'm going to be replacing the values by -1. I have done this like in a recent one of my latest, like before I took my little break thing. So we are actually iterating the old fashioned way for I in range of the length of neighbors. The len, just the len, not the leng. So we've got an iterator that clicks along quite nicely. And I'm going to say n becomes equal to self._grid at okay, if so this might already contains -1 if we've got invalid squares. So if the neighbor I'm looking at, the index of the neighbor I'm looking at is -1, we continue. Just go to the next I. Otherwise, I spelled it the right way, right? I pick. So this is a bit like nested indices. This I is just going to be between 0 and hopefully 7, right? Because there's 8 of them, the neighbors. And if it's not -1, I get whatever's in that neighbors list. This is an index in the grid list. And then if I get at what as an index in the grid list, I get a cell object. So I should have called it cell. But if I'm going to need a getter then, I guess, on my class cell real quick, which is a def has cinnamon self return self._cinnamon, right? Didn't pick the, yeah, no, it was here, right? So if n dot, which is a cell object, it was has cinnamon. Let's spell it the same way. And then I'm saying neighbors at index I becomes equal to -1. So it's saying actually there's not a valid cell you can move to, which means that whether we're in pheromone mode or in random walk mode, an on that is looking for food, which to be fair, they may have told us, yeah, an on looking for food will not enter a cell containing cinnamon. That's what they meant. The scent of cinnamon is so strong it also removes all the food, making it unappealing. It doesn't really matter because the ant looking for food doesn't really doesn't have any idea where the food is until it's gone right on top of it. And obviously it won't be able to get right on top of it because it cannot enter a cell with cinnamon. I can't believe that we're just cannot update. So this is going to be another one, right? Kind of like entering, we're doing the entering, that's fine. And adding pheromone to a cell containing cinnamon, this is going to be a tricky one. But that, okay, so I get the neighbors, which are the indices of the neighbors, but that's like one big list of indices in the grid array, the self_grid array. Some of these indices may already be equal to -1 because they're not valid locations, so they're not valid indices in the grid array. I'm iterating over this list using an explicit number iterator. If the index I find at this location of my iteration is -1, it's not a valid neighbor, we just click over and I becomes equal to the next one. If we find one, we pick up the cell object, we test whether it's got cinnamon, and if it does have cinnamon, we set in the neighbors list the array, which is an array in the underscore grid, right, to -1. So when we pass it in here, it's not a valid location for the ant to move to. But that's only the beginning. So the way it adds cinnamon is cinnamon adds the way ants, here we go. This is here. When ants are carrying food, and this isn't an else, right? So this is, they're under the nest, they're carrying food. They're at the nest, no, sorry, they're not carrying food, but there's food on the ground. So they're loading food. So say unloading food, loading food, anything else. If they have food on their back, weirdly, we're going to do this whole effort. Like even when we're carrying food back, we kind of do the neighbors and get index because you pass it with a consistent signature. But the point is, this is where we want to intervene. Well, not bracket A, obviously, but right, for P in cell pheromones, if P in same location, A has been given A, get ID, and P has the strength from strength return. Well, okay. So how would I go about doing this? So this only updates the pheromones, it doesn't add pheromone. This is the strength, and we delete if they get too weak. So update unpheromone cell. So this is just updating them, but it's not adding. Remove pheromones from cell, that's helpful. Add food to cell, surely that, yeah, you'd think that. Pheromone, okay, not this, not this, not this, not that. Oh, sorry, yes, this would append, this would create new pheromone that adds pheromone, but before that, if we have some, we'll have it. So we know that if the aunt is, so this takes care of, this is why, you know, of course, aunts are allowed at carrying, only aunts that are carrying food lay pheromones, because pheromone is meant to kind of indicate where the food is. And although aunts looking for food cannot enter a cinnamoned cell, as we've seen, when ants are coming back to the nest and carrying food, they can, right? We're not checking for this. But it's important that if they are in one of the cells, if they pass through, they're not able to lay pheromone. So we know that we don't need to touch the update because when we inserted the cinnamon, we wiped all of the pheromone in that cell. What we need to do is do this here. So we have A. Okay, right, so I need to just do cell, well, C is equal to, well, cell, okay, the cell is equal to self dot underscore grid at index self get index of A, get row, A, get column. So you will see this, but you see this everywhere, right? Like if you do self dot this is how you get, you know, you have a specific location, you don't want it, you want to know which cell is at this location, you get the element inside self grid of the simulation class, obviously you need to be in a simulation instance, and then add the index that you get back from underscore underscore get index at row column. And this will appear like plenty of time in the code, right? To get the current cell. Of course, only in simulation because you need self.grid, you need self. Like this is, well, no, actually, that's get indices, not get index. So this pattern appears everywhere. That's the cell. And then I just do if not cell dot has so we only add to, you know, we only lay new pheromone if there isn't, it's not has pheromone, it has cinnamon. Because of the cinnamonaldehyde aldehyde and seek. Okay, I'm feeling tentatively lucky. Simulation 1. Okay, 5. 15 stages. I mean, I hope I've not killed the whole colony. No, okay, that's looking pretty flourishing. Okay, a cell containing a high level of pheromone. I mean, there's a bunch of food, there's a bunch of ants in here. It's going to be 1 free, right? Sorry, back here. 6. 1. 3. Boom. Yeah, I did meant double N. No, I did. This one I misspelled. Oh god damn it. That's Cinna. Yeah, that doesn't look right. 2 N's, 1 M. Cinnamon. Phenomenon and cinnamon. Okay, so mission 1, 5, 15 stages. Check out what the details are. 12 pheromone here, 50 food. And so it's going to be what, 3-1 again? No, 1-4. Okay. Check a 6 in here. No. 1-4. Oh yeah, but that's not done anything. At least it didn't break, so I'm happy. Obviously we don't. Whoa. There's 4 arms. It has wiped the pheromone and it has wiped the food, which is kind of what we wanted. So those 4 arms, I mean, what knows what's going to become of them. Advance 1 stage, display. I guess they're on their way back to the nest. I don't know. This looks like it worked. Yeah, all the pheromones removed from the selected cell. I suppose we shouldn't have removed the food, but like they were unclear in their specification. So let's have a look at the defo. Sorry, defo. Right. Original select for compare, Z18 compare with selected. And now the diff I need to be looking here. Right, okay, from the top, classic new menu item, right? So there's a new elif in that conditional structure. I'm pretending to look like this, like the code is not here, but you get it. This calls our new method, get pheromone. We need to. They look very similar. I was actually wanted Z19 for compare. That's my problem here. Okay, do it again. Select, no. Select the original for compare. And compare that with selected. Okay, so new menu item, we need to display it, add cinnamon to cell, and the new menu item, we don't really need these, but whatever, same deal, we know how to do this, right? Again, like, I don't think they will ask you anything that hasn't been done in some similar form somewhere in the code. So things like in same location, things like the other things, you know, get index and like all of those design patterns, get cell reference, you could use that, using that everywhere. So we get a new row and column from the user and then just call this new remove pheromones from cell, which is here. What this does here is our old double list trick, right? You kind of initialize a list of stuff you want to remove, you go over the list you want to remove from, you make a note of the ones you want to remove in your to remove, and then you iterate over the new to remove, and then removes the ones you want to remove. I think remove a lot from the list you want to remove them from, the list from which you want to remove them. Yeah, that's better for a diff, right? That's one thing. And the second thing is I have a new add cinnamon method to the cell. And again, same design pattern, self underscore grid, bracket, self dot underscore underscore get index, row column, gives you the cell at this grid location. This is for the not adding pheromone, which is just literally get the cell where the aunt is. And if it has cinnamon, and there's another getter I added to the cell class. If it doesn't have cinnamon already, obviously, then only add pheromone if there isn't cinnamon. Problem is pheromone and cinnamon sound, well, they don't sound similar, but there's like 3 syllables and non. It's kind of, yeah. This is the meat. So in order to avoid an aunt looking for food going into a cinnamon cell, I need to remove them from the, which I'm sure I've done in a previous one in some shape or form, remove them from the list of neighbors, which is actually a list of indices of the neighbors in the self underscore grid of the simulation class, but list of neighbors that we pass to the choose cell to move to, which was where the 3 types of ant workaround movement happen. So first this used to live here, right? Kind of, you can't see the left-hand side of the diff, but this used to live here, right? Kind of in choose cell to move to. The first argument used to be straight up this call to get indices of neighbors at this row and column. Now we chuck it into a neighbors variable, and we're going to iterate over it using an explicit number integer iterator. We only want to look at the ones whose value, don't get mixed up, right? Because like here, I is the index inside the neighbors list. That's going to be between 0 and 7. That neighbors list itself is going to be some integers, which are going to be indices in self_grid, or -1 if they're already blocked out, because like typically it's the edge of the map when the basic game, because we don't have anything that excludes cells. So if it's not an excluded cell, we're getting the cell object. This n for neighborhood could really be called C or cell, and if it has cinnamon at this location in the list, well, there used to be the index that we got from the grid to get the cell object. At this location in the list, we write a -1 to indicate this is not a valid cell. And finally, we just pass on that slightly doctored list of neighbors to choose cell to move to, meaning that once we go into the workaround code, nothing's been changed, right? Cell has been changed, but like all of my aunts haven't, because it's not even able to go to consider as a valid location the cell that gets cinnamon. As to the cinnamon itself, they wanted to have a way of doing, and they're not wrong, right? Because they were super helpful to use has cinnamon as a true-false to test on to say, oh, can we go in here, or can we not, or can we lay pheromone in the cell or not? So in order to support this new flag, we need to initialize it to false, because by default, like, cells do not have cinnamon, and I just have a new add cinnamon method with which sets it to true. I'm also wiping the amount of food because they've had this slightly ambiguous wording, which I've now lost, but kind of you're only seeing a bit of it. But was it? The scent of cinnamon is so strong it also removes all the food from a cell, making this. I feel like scent cannot remove food. I mean, it's got to be very strong to be tangible and actually look for that. So I don't really know if I needed that change. And in fact, when we tested it, they were like, can you just check? Why am I, sorry, here. I don't even know if I needed to like set the amount of food to 0, but when we tested it as well, we only checked that, no, it's that way. We only checked that the pheromones have been wiped, not the food. This had wiped the food, whatever. I think I can remove this, the code's gonna behave fine. And then we have a has cinnamon that returns the value of the flag. So the flag starts at false, and then is only set to true if we add it, and we call add cinnamon, remember, in the remove pheromones from cell, which is really it does more than this because it adds cinnamon to the cell. So a cell without pheromones is not enough to judge. That's why we need this new flag to say have cinnamon. Similarly, a cell without food wouldn't be enough to judge. We do need that new flag. They're not wrong about this. And that's your diff. Cool. Yes, Zach, the electronic answer document, we can do that quick. I don't think there's any, I mean, there's a 5 and 8, for 5 and 8. Huh. I don't have the Word, I can't open like Word docs in there. I might do like a video just for this, but I feel like this is, I mean, you can see there's some tables. There was a table that had like no column headers, which is always a little bit worrying, but it could be anything. But the key thing is like a 5, an 8, and then 2 12s? Something like that. But it's always like this, right? You get like a small question, which is typically, but not always, input validation, because that's a nice thing you can do for 5 marks. Slightly bigger one, and then a couple of chunkier ones, sometimes like a made and like an even chunkier, but like, as we've seen in my previous live, and I really want to make just a short video about this, because it's probably the most important thing to know. Like if you attempt all the question, you can easily get like up to, I think, 10% of the value of the marks of the paper. So that's quite something. I don't know if I want to I might do like VS Code is Microsoft, Word is Microsoft. You'd think it could do it like right off the bat, but it doesn't. 20, is that the last one? It's the last one before the extensions. Okay, so now this completes. In the skeleton program, worker ants move randomly looking for food. What a tragic life. This could continue indefinitely. Well, yes, this is it's quite concerning. What's the proposed solution? Question number 20. Introduce the idea of backtracking once after 6 steps of unsuccessful searching. Wow. This is interesting as a task to the task to code. This is like really, like all of the ones, they're kind of really weird in terms of simulating an on thing, but doesn't doesn't matter. Or pheromone trail. So this is only, right, there's 3 modes of motion for the ant. It's like I will do a video on the. I think it's starting to occur to me that like lives are quite long, and I just don't necessarily chapter them correctly. So if there's stuff that's in the middle of the live, I can't be trust that the audience will see it. So we want to backtrack a term we know from graph traversal algorithm, which means we're going to need to keep track of how many rounds we've been without finding food. How many stages, I suppose, is what they call the clicks of the simulation. Okay, don't need this, don't need that. Just look at it, like a quicker look at the question. All right. Suitable data structure to work in class to store the position history. Oh, right, this is an actual fallback track. Okay. Okay. But that's not gonna, that's just not what? I mean, at no point do they tell us like you kind of need, it needs to move 6 times without finding anything before it backtrack. I mean, Zach, I would say they calibrated with the same difficulty. There's a debate here, like the difficulty of N simulators compared to the last year's pre-release. I mean, specifically the last year, what you have to bear in mind, I had the last year, it's not, I've got a whole other document, if I've brought it in there. But when I looked at the, yeah, right, there was kind of like the 2024 QP and mark scheme. It was really interesting. You don't have the code in that one, but like if you've looked at, this is actually not last year, sorry, this is 24. This was the last year. This is the one available on Physics and Math Tutor. Last year's Target Clear was its name. The year before was Symbol Puzzle. Target Clear was really odd when it dropped. Like when the preliminary material was published, I'm not super plugged in because I'm not on like Facebook or Twitter, but from what I can sense of the community of like, I was about to say like UK teachers of computer science, but like those are specifications that are taught in this internationally, of teachers of the AQA A-level computer science. We're all like, oh my god, there's no OOP. And it is true that like OOP is, but not solely, but like OOPS is like one of the massive new things that's on the A-level that's not in the GCSE. I'm often keen to reiterate to my colleagues and students that the programming stuff that is now seen at GCSE, this is stuff that I would have seen as a sort of undergrad in science and tech generally, at this sort of undifferentiated undergrad, and then OOP, functional databases, I guess, right? Like kind of, let alone things like big data and AI or whatever that hadn't kind of, well, not been invented, or a bit different in like 2005 or 3 or 4. But like OOP is something I only saw as a postgrad computer science in like 2004 maybe. So OOP is a big deal. So when there's no OOP in the skeleton code, they're like, that means they can't really, well, they can't assess any of that area of the spec in the skeleton code. But the skeleton code is only section C and D. Now, of course, you can't, they will never assess OOP on the section B. That would be like far too cruel, because there's just meant to be a 20-minute self-contained thing. Asking people to design some classes feels a bit like beyond the scope of this, which leaves really, I guess, section A to evaluate, to assess it, or it not being assessed in 2025. And I would have to have a full look at that question paper I was looking at, which is not the right one because it's 24 anyway. So next year I'll have a look, but like their duty, like AQA, the rule and like the other boards, right? But like I know that for AQA it is the case. I'm not sure, like details may vary, but I got it from an examiner at AQA that their goal is to cover the whole specification, 2.5 hour exam, right? Like 2 times 150 minutes exam, that's like 300 minutes for like 2 years of learning that you can't test absolutely everything. So we know there's going to be gaps. It feels like this year, maybe as a bit of a reaction from last year, they've gone like very OOPy. And I don't think, I mean, I would have to double check, right? But like this looks like there's a more complex class structure. I mean, I still have I still have this. This looks like what a far more complex class structure than in any of the previous ones. But ultimately, this whole stuff is calibrated, so it's kind of the same difficulty overall. But again, like things that may, like, if some part of the specification are tested in some areas of the paper, or not tested in some areas of the paper, so here, they need to be tested somewhere else, or maybe tested like within the next couple of years. What's interesting as well is that, I guess, like since the pandemic, I don't know, I've not really been a teacher for very long, to be fair. But something with the social mediums, and actually exactly this kind of stuff, like the kind of basically teachers moonlighting, influencing, particularly during exam season, because apparently like this is the only time children will watch educational YouTubes. The big, like the thing about like predicting what the paper is going to be has become a massive thing, and like influencers will kind of give their punt. And I was quite shocked to see Physics and Math Tutor, the website that's not just for physics and maths, because they get a lot of computer science, to also have their prediction. And it's like, I mean, it depends what we're looking for, but like even as someone who's like, well, you know, an exam is just an exam, it's got nothing to do with learning or whatever, the idea of like, well, I'm just going to optimize for like what I think is going to drop, and then like just like really push on this feels like a more dangerous strategy, that even if for the same degree of knowledge, which is difficult because you'd have to kind of either distribute it over a lot or like very deep into one area, feels like kind of dangerous. So I will not make predictions, and more or less difficult. I mean, the boards as well, right? Because like before they come out and mark everything when it's marked, they kind of like mark a small set and they calibrate and they redo the mark scheme and they design what needs to be accepted on it. It's actually kind of a whole like thing, marking exams and like making good exams. But I'd be very curious to see like what is more difficult than one or the other. The only people that have visibility over this is AQA, who will have not just like kind of the letter grade, because they keep shifting the grade boundaries to make it look like they want, but like the actual percentage points, kind of like median, min, max distribution of like scores on each of the questions of each of the paper. I'd say, I don't know, last year's, what was this, like I'd probably say it is a bit more difficult, because I felt like last year's had simpler data structures, where here you're always messing around between your underscore grid and having to remove things from this and that. Like last year was just like a straight up, if I remember correctly, I'm not even sure, but like a straight up list of targets and things. But yeah. Okay, let's make, have I made my Z20 already? Hang on. Update. Do I want to update? No. May 20 was just yesterday. I mean, who knows whether it's in magic. Have they put Claude, whatever dumb AI bullshit we're tripping about now. Yeah, you're right, Zach. The live class, I probably should really have a think about it, because there's only 10 days to the exam. I'm guessing next weekend. I guess. I mean, to be fair, you guys have time because it's study leave. Yeah, I will send that email. I think, do I need to show do I have a thing for the live class? Can I display something? Whatever. I'm just getting a bit distracted. All right, like for the people that are watching on replay, and I'm not kind of not keeping up with all of the cool tea and buns in the chat. Okay, so we're gonna go to workaround and store a position history class. Well, class workaround. Right. That makes no private. A path history. I like path because it's, I don't have to justify myself. I like path. Ooh. Okay. Well, I mean, it is an appropriate data structure. It's a list. That's fine. To add to the data structure, one can move from cell to cell operating as described. So I don't have a point in the code after. Well, no, actually, I do have a point in the code after it's moved. When I'm at the bottom of this, right? There's like 3 branches in there, but like I always end up here. and it's going to be self dot underscore underscore path history dot append. Now the question here is like, what do I want to append? And I think I've answered my own question, because I was like, we could just append, like add cells, but we can't, because cells are only known by the simulation class and its underscore grid element, meaning I'm just going to have to go by row and column. So we're going to append. I'm going to do a little tuple self dot let's go row self dot underscore column. Okay, so I'm not doing the backtracking, it's just keeping track of the path. Should we just test that? Okay, and oh, this is important. Yeah, okay. Now I can find footer of pheromone trail in the 6 stages. The movement history should be reset. Now, the problem is the workaround class does not know about finding food. It knows if it's got food on its back, right? Which it's going to tell you what's going on, but like, I guess. Now, you know what? Yeah, okay. So actually, I'm only going to add to the path history in the bit where it's actually looking for. Oh, wait. Or pheromone trail, right? So like pheromone trail counts as a victory, right? If I find food or pheromone trail within the 6 stages, should be reset. So actually, we only want this here. This is the one where we've not found, there's no pheromone trail. Here, it will find, we have found a pheromone trail. So in this one, I'm just gonna say, and here we're moving back to the nest. So I don't really need to wipe it every time. I could wipe it from this. I could wipe the path history of the worker ant from the simulation class, because the simulation class is the one that really knows when the ant is loading food on its back. But what I'm just going to do is, like, if we're moving back to the nest, particularly in the first one, but we're always kind of like zeroing this. And this is where I'm going to like check length of path to backtrack maybe. To backtrack maybe. To backtrack. Comma maybe. If it's larger than, well, whatever. Well, we can deal with that later. And they wanted another method called backtrack. Just backtrack to previous cell, which means we can back to a cell location from the previous cell. Stop where. So obviously, if it's only backtrack to the previous cell, it shouldn't have a stop condition because it reaches its nest, because it only should go like to the previous cell. So this is just like really badly specified, which I absolutely hate. And then we also want a message. So like those are, what is it? Like when backtracking, the ancient backtracking and which station is progress. The real important thing that they are testing here, and I suppose that this is, because you always get stuff that are crossover, right? And this is a stack question, because your path is a stack, because if you backtrack, you just go back to the previous one, but you don't add, and you also pop, you get it, right? Kind of like we're rewinding history, very much like the typical stack data structure that you know about, like in real world use, is like a browser history, or like an undo, redo, yeah, kind of stack of actions to thing. So backtrack to previous cell is the name of the method. Self, because it doesn't take any thing, and I'm immediately going to go okay. Row column is equal to self dot underscore path history dot pop. Now this is gonna throw an error if path history is empty, but thankfully I should never call backtrack to previous cell on an empty path history, because the criteria to start backtracking is the length of path history is larger than 6 or 5. The problem is that, like, if you do it before or after the movement, it will shift things by 1 in a slightly annoying fashion, but usually for this kind of stuff they will accept both versions in the mark scheme. So print f maybe ont, do I have to the ont number? Yeah, it's ID and backtracking and which cell, and that it is backtracking in. So, yeah, okay, fine. So it's ont cell dot get ID. Very good. So I've popped them out of my stack history of the path. I've logged a message, and now I just basically need to move, which is just as simple as setting self underscore row becomes equal to row, and self underscore column becomes equal to column. 6 steps. Within 6 steps of what? Well, I guess of looking, which is like, because they start from the nest. Okay, so they'll start from the nest. There's no pheromone, so they go in there, they move once, and then that puts the path at 1. Like, the path history is of length 1. So if I test it for 6, yeah, once it does the 6th random move without finding food or pheromone, then yeah, okay. So if self dot length, if the length of self dot path history is larger or equal to 6, then it's unclear whether we backtrack all the way to the nest. It backtrack for its route all the way back to the nest before resetting and going back out again to forage for food. So resetting, this kind of stands at the flag, you know, that you should have maybe a flag that says I am currently backtracking, and once you hit the nest, you kind of wipe that flag back to 0, because this cannot get called. My new function backtrack, which was here, right, cannot get called from outside, from the simulation class where all of the rest of these things are decided. It can only be called from within my, although it's public technically, and it only takes the self. So, but they're not telling, oh, you should modify the advanced stage in simulation class. So I don't know, but it's unclear to me whether, I mean, like, what type of backtracking are we talking about here, right? Because if we just, it reaches 6, click 6th, still haven't found one after the 6, I backtrack, go back to the previous one. What, like pick a new random one from the previous thing? Doesn't really make much sense. So we're going to go like 6, 5, 6, 5, 6, 5, meaning it's just going to kind of like, because it's not really keeping track of the one it's tried, right? It's going to be on that last or that number 5 location and try a whole bunch of 6s around, because none of these, unless there's a pheromone trail that gets laid in the meantime, but none of the neighboring ones are valid, then it's going to get stuck in that loop. So clearly they mean to say just backtrack all the way back, but I can't, I need to keep track. Oh, so 9, fine, okay. I just need to have a new flag. I could not I need, it's a state thing, right? Like either the aunt is actively looking, or it's reached the maximum like 6 steps before just like decided to just give up and go all the way back to the nest. And it has to be able to go all the way back, meaning there needs to be like 6 stages and clicks of the simulation that by default are going to be calling choose cell to move to, which yeah, I don't know, not kind of backtrack. So nightmare. Well, no, not necessarily nightmare, to be fair, right? This kind of this will do the popping. which means that I can't test for this. Well, I can test for this. Right. I'm going to put a big if here. If self.backtracking. If that is equal true, right? I'm going to self._. Oh, not underscore, backtrack to previous cell. So as long as it's backtracking, it's going to be backtracking to previous cell. And in here, if the path history has reached 6 or more, I'm setting the self.backtracking flag to true. And then in here, which is going to get called from the simulation class advanced stage, clicking them along by stage, choosing the cell to move to, and then going in here. Do I have the carrying? Yeah, nest and row, nest and column. And in aunt, yeah, nest row, nest column, right? So I don't even need, well, I can't do get, in same location, because for need to do this, I need to have an entity object, and the only instance or place of the code that knows about nests as entities, instances of the entities class is the simulation. So again, it's kind of like the scope of what bit of the code know about which other bit of the code. But, oh, hello, yeah, cool, right. I have a helper function here called isAtOwnNest. So in here, no, not nest, workaround. Okay, cool. So I've moved it, and if so I have this that does exactly what I needed to. Now at this stage, hopefully, I should have popped everything, right? But I'm not trusting myself to do that. So I'm just going to reinitialize like my kind of, backtracking attribute, which is the path history and the backtracking flag. And this is helpful. And I state the message. If it finds food or thermal provenance stage, the movement history should be reset. Yeah, I mean, that's gonna stay wiped. It's not just reset, but like it's found it, like, and it's gonna stay reset until we get back to the nest. In which case, because we're gonna get back into this, do I need to? Yeah, I'm appending to the path history. Yeah, that should all be. I think yeah, I think we're done. I think the task is complete. Luna, we could do this, but that feels unnecessary. I mean, it depends what the constraints are, right? But like, you're right that it feels like, I mean, this was like the path history, right? They did mention a suitable data structure. They don't mention your point here. I mean, the point behind your question, which is like Luna is making a suggestion that we could just like chuck a number 1 in the as the food carried, and then the workaround will just like kind of follow, basically go straight up to the nest. The first step that would work, and then you would have to remove that one food in the simulation class. That kind of would work, but remember that like we may have done like a route around the nest that's not the straightest path, whereas the return is going to return by the straightest path, because if we return because we get food, we try kind of like return by as straight a path as possible. So it doesn't really kind of meet the brief. But the reason behind your question is that really they have told us that we need a data structure, which I have. That's my list of path history. They didn't tell us that we need to have a flag to keep track of whether the aunt is currently backtracking or not. And so you're thinking, well, I wasn't asked to get a flag, so rather than just add a tiny Boolean flag and then like set it and test it in the correct places, I'm gonna piggyback the architecture of the food, like, kind of backtracking and depositing to get aunts to return to the nest. to do that? Well, it does get them to return to the nest, but it doesn't really get them to backtrack with the original route, which leads me to think that, yeah, I think it's cleaner to have its dedicated thing. Again, I say again because it's maybe not, maybe it's the first time I said it in this video, but like the zigzag tasks are really not representative of the type of specification you get into actual AQA exam tasks. Those will be paint by number. If you need a flag, they will tell you. If you need, they may say, oh, a suitable data structure, but like they will tell you need a new attribute. They might not tell you it's a list or a dictionary or whatever, but like they will, tell you method, change this one, add this one, whatever. So we're often dealing with kind of a degree of ambiguity in this. Am I testing this with 1? Oh no, 4. Oh, weird flex. We're dealing with a degree of ambiguity in the zigzag task that's kind of not really representative of that. But then, as we've seen, it's kind of really tricky to design an exam well, and you can't do like something. You can't do 20 tasks worth of practice with like exam level spec. I'm kind of warming up. I used to think that the zigzag tasks were not that great, but the more I use them, the more like, actually they're probably the only ones, just like I guess I'm the only one on the internet doing this. I think zigzag are the only ones in the publication who are doing that. I know there's the Wikibooks one. In fact, I suspect zigzag rip a lot of them off from Wikibooks, but what can you do? They actually speculate, by the way, about like, what is the 5, what is the 8, and so on. All right, 5 multiple stages, 7 stages, and nothing is backtracking, which... Okay, sorry, make that bigger, make that smaller. Okay, well, I get the feeling that we're not... maybe they're all finding the food far too quickly. I don't know. Excellent, right, now there's some backtracking. Backtracking to 5-1 and then to 4-2, which is connected. It's in diagonal, right? 3 is backtracking, was in 4-1, goes to 5-2, and then boom, right? Then I have this problem here, which... yeah, I'm trying to pop for an empty one. This is enough by 1 error, so I think I need to put my test at the top rather than at the bottom of the function. It's kind of a classic one. Because we might already be at the nest, but we're still in backtracking mode, because it's the backtracking method that discovering it is the ant is at the nest will flick back the new flag to false to say we're now in from tracking, like going forward rather than back, which means that I need to put it here. Cool. And so we might have an empty path because we've backtracked everything, but be at the nest already. In that case, we need to check that before rather than after. But if I had added to the path, by the way, it does also mean that the reason I can find myself with an empty path but at the nest is that the coordinates of the nest, the cell of the nest is never going to be in the path history, because you write the path history after you've moved, right, as to the new row and column. So the nest cell is never in there. There's always the last one, or the first one in the path history, or the last one we're backtracking to is always a neighbor of the nest. So, which is a bit weird. Is that right? Yeah, maybe that is wrong too, because it feels like we could never get back to the nest because we're going to get back to the nearest neighbor, but then we don't know where to go from there. So I think I'm still going to have the error because I'm not at the nest yet, but I still can't pop. So I think I might need to put them in, which is append, to move that before the update to row and column. It's a lot of this that you need to sort of trace it in your mind to see what happens before the other to figure out what's going on. So let's try that again. Submission number 4 with a 5 and 7. Okay, I'm digging this, although they've not... they all started to backtrack. Ooh. Yeah, this has yielded the same problem because we were at the neighbor of the nest, but not there. The question is like, how can I have gotten this when, right, I advanced by 7 and I've only seen, right, there's like a bunch of them that are backtracking, but only by 1. So the fact that if the path should be 6 long, right? The fact that like after the second one, don't even know which one it is here, because like Ant11 was able to print its message. But this is why I need to append it. Fine, so I think if I put it here, that should work, but if not, you know, I'm just going to declare oh, not 7, 5 and then 7. Right, so we're doing a lot of backtracking. That's looking promising. And they're continuing to backtrack. They're zeroing in on, and we're popping from an empty list. One 5. And before that, it was really 12. Presumably it is 12 that's breaking. 2, 5, 1, 5. Don't know where the nest was. It might not be from the default nest, because in 4 there's more than one nest. So I could put in a, you know, if the list is empty, don't pop from it. But yeah, I worried. I mean, we're going to have a whole bunch of other issues because we're not going to be able to get row and column, and so I guess it's going to be breakpoint. I was really hoping we wouldn't come to that, but okay, debug it. Okay. Four, 5, 7 stages. Hello. Okay. I'm gonna need I'm gonna need self, I guess. So work around object at whatever. Nest row, it's row and 5 and stages. What's my path history? So the nest is 2, 4, right? And we see that the first entry in the path history is 2, 4, then 3, 5, then 2, 4 again. Fine. Which means that surely when we backtrack, we should encounter it first. Yeah, fair. If it's going to visit in the nest once on its kind of 6 long path before backtracking, then we'll stop at the first one rather than the, you know, kind of very, very first one. The first one we encounter backwards. So the last visit to the nest in the path history. Okay, but this is, yeah, that's not telling me much. N2 is backtracking to 4, 5, fine. And 3 is backtracking, yeah, they're all kind of happily advance one stage. So Ant2 is, now there's 4 in the path, right? Because they've backtracked by 1. Advance one stage. Okay, I'm gonna have a let's call path. Why is this? No, it's self, right? It shouldn't be a class. It's not a class attribute. It's an instance attribute. History double underscore. Yes. Okay. Right. We know they're backtracking true because I'm only breakpointing on these. Let's just have a look at this, right? So now we're seeing the amount reduce in there. Oh, this one started at 9.9. That's interesting, right? So like there's the second set of ons are from different nests because we're in simulation 4, which is larger. And 6, 6, and then now we go to the 9.9. Oh, right. N12 this is a new backtrack, right? Oh no, wait, it wasn't the previous one. Don't know what's going on. It seems to have a very full, Do you know what? I'm gonna do 5 and then give me another 7, right? Because that way I'm just gonna have to click the thing. Okay. Oh. Oh, sorry. Just I'm being daft here. I just, of course, once I've done this, I need to return, right? Because like I don't want to be doing the pop and the. That's right. So we were at the nest. We had reset to backtracking false. We have an empty list. In fact, we may have wiped something, kind of a moot. Yeah, because if if we went through the nest a couple of times in our meandering, and when I backtrack the first time I encounter it, I just wipe the whole path and stop, cease to backtrack. So we may discard, like when we kind of wipe it again, we kind of may actually discard active, valid paths. Anyway, so let's run it without the debugger and like confirm that 4, 5, 7. Hey, did I not save it? I did not save it. That's the problem. Okay, 4, 5, 7. Yay. Right, this says stop crashing, so I'm not saying I'm happy, that maybe slightly overstating it to call it not, where's my control B? Yeah, all right. But I guess I wouldn't say satisfied. Right, 2-4, like the 2-4 means they've kind of reached the nest, right? Because the first nest is always in 2-4, or is it? Yeah. Oh, there's one in 2-5 as well, that's helpful. I could put like more messages, right? So you'll notice, right, my 2, 3, 5 that had reached their nest are now out of the list of the ones that are backtracking. That's kind of good enough for me. Right. What I could do here is have a little print. Self.get ID. And curly self.getted backtrack. Right, let's just now get like errors, like messages galore. Right. So we see them starting to backtrack, then continuing to backtrack. 10 has backtracked to the nest. Don't know how it managed to do that in 1, but it must just have kind of like, because of the random walk, you might not be getting very, very far away from the nest. And yeah, advance some more stages. Number 7, right? Kind of like this is at least stable. All right, and this was the last in the zigzag. Okay, let's have a look at the diff. Ta-da! Right, so this doesn't have any of the usual, like new menu item, whatever. Well, literally, this is kind of just the workaround class level. In order, I have a new path history. The appropriate data structure is, it's a stack in that instance, but like obviously we're implementing over a list. But remember, like this is given to, there's 4 different languages supported, and some may have native data structure that might be closer to what we want, but we're going to use pop. And we're using append, but that could have been called push. And we need a flag to figure out whether we are currently backtracking, and keeping track of those 2 new attributes is key to this change here. I'll come back to this in a second. I just want to put the change over here. So if we are in backtracking mode, we're going to call the backtracking, in order to choosing the cell to move to is a matter of backtracking, we just call the appropriate method and kind of delegate it to that dedicated method. Otherwise, if we are in returning food mode, or if we are in found a pheromone trail, the path history is blanked, right? So that way we're not counting, because the criteria to go into backtracking is this one. We populate the path history before moving. So as we get asked to move and we notice that we are in a random walk move, then we're like, okay, I'm making a note of my current location before it becomes my previous location. Then this might need to be a 7, I guess, but like doesn't really matter. And at some point is after doing this, we will move once, but if there was like the 6th thing I visited, including the nest, so maybe it should be 7, without food in it in random walk, I'm going to say we enter backtrack mode. I've added a little message here. And the backtracking mode that we're entering here, we're testing in here, getting it back in here. First thing I check is, am I at the nest? If I am at the nest, I'm going to wipe the path history, meaning I might not fully backtrack if I'd gone to the nest several times in my forward track, but I'm just resetting this to where it was when we instantiated and created the workaround. If we're not, there's a return here that you need not to forget so you don't get the pop error. If not, I'm just getting row and column from the pop. By the way, I was just appending them as tuple here, right? Kind of append bracket self row self column. So they come back out as tuple, meaning I can just do double assign row column becomes equal to this. Printing a little message as they asked us, and I'm just setting, this is how you move them, you set the current row and the current column to be row and column. And all of this together gives you the backtracking behavior that they were after. Right, that was the whole of the 20, have I got it here? The one we did today. No, wait, here, okay, got it. This was all of the 20 zigzag tasks. I know I owe you a couple of dedicated videos, but I think from this point on I might be more doing live streams if you've got questions. I will, can I display the link to the live class? I will put the link in the, I should have say that at the beginning of the video, didn't I? There's going to be a link in the description of the video to maybe a form so that you can sign up to doing this kind of thing, but like live on Google Meet. We'll see how it turns out. Thank you for watching. Best of luck. I'm sure you've got plenty of other papers and other subjects before next Wednesday or Wednesday week. But in the meantime, I hope that we will be seeing a lot of each other again.